We've spent so many years wondering about the secrets of our own moon that until very recently, we've not paid much attention to the moons of other planets. But some moons out there are phenomenally interesting places, and finally we have the technology and the drive to investigate them. And we're making a lot of discoveries. This is Unveiled, and today we're answering the extraordinary question, what are Ganymede's massive, mysterious craters? Do you need the big questions answered? Are you constantly curious? Then why not subscribe to Unveiled for more clips like this one, and ring the bell for more thought-provoking content. Ganymede is the largest moon of Jupiter and the largest moon in the entire solar system. It's even larger than the planet Mercury. But even though it's visible from Earth, because it's so far away, we know very little about it. It's an extremely intriguing place, however. Although to the untrained eye, Ganymede looks like any other barren moon, much like Earth's, scientists have growing evidence that Ganymede is actually covered in ice, and that it could have an underground ocean beneath all of that icy exterior. Callisto and Europa, two more of Jupiter's 4 Galilean moons, are also thought to have large deposits of ice and potentially even oceans. Like Ganymede, Callisto has been ravaged by impact events, making it the single most cratered celestial body in our solar system. However, it's the craters of Ganymede that take center stage for today's video. Thanks to images from the NASA space probe Juno, we now know that the craters on Ganymede are far more numerous and larger than what had been originally thought. There's even one that's 68 miles wide. The Juno space probe was launched back in 2011, and it entered Jovian orbit 5 years later. It's been orbiting Jupiter ever since, sending back stunning images of the gas giant and its many moons. But of course, Juno wasn't the first space probe to see Jupiter. Voyager 1 and Voyager 2, the two oldest artificial objects still operating in the solar system, both saw Jupiter as well. Both were launched in 1977, and as of this writing, are still functioning, decades after their original mission ended. Importantly, though, the Voyager spacecraft didn't enter orbit around Jupiter. They continued going so that they could provide data on the furthest parts of our solar system and are now billions of miles away from us here on Earth. The New Horizons probe, launched in 2006, also did flybys of Jupiter so that it could perform a gravity assist. But its primary goal remained the exploration of Pluto, and so it's headed there without stopping by Jupiter for too long. It's been providing a wealth of data about trans-Neptunian objects and the Kuiper Belt ever since. The fact that the Juno probe remains in orbit around Jupiter and will remain until it stops functioning, which could be many years from now, is what sets it apart. It means that it can keep sending back to us a series of stunning, high-quality images. Which brings us back to the craters on Ganymede. Among the images sent from Juno are some that have led to the discovery of never-before-seen marks on the surface of Ganymede. Upon analyzing the latest pictures, scientists have explained that while the craters were obviously there before, we just couldn't see them because the previous images we had of Ganymede, taken by Voyager, just weren't good enough. Indeed, capturing a single shot is difficult enough. Depending on what angle the camera is at and where Ganymede is in relation to the Sun, the topography of the moon can look completely different. The same is really true for any other object, including the human face, which can look significantly different depending on where a light source is coming from. But it means that any one image of this alien world taken by one spacecraft at one point in time could potentially produce all kinds of strange perspectives. And it's only when you have additional images that you can really make sense of what you're seeing. One particularly famous example of this from elsewhere in the solar system is the face on Mars. The original black and white face on Mars image was taken by the Voyager 1 probe in 1976. It's a region of the red planet called Cydonia, and has been a magnet for people trying to find proof of intelligent life away from Earth. However, more detailed, more contemporary images show that the face on Mars is actually just a rock feature. It was the particular shadows captured in the original image that had made it so evocative. But they're obviously not a constant. Similarly, the lighting just wasn't right in the original images from Voyager for us to properly see the massive craters on Ganymede's surface. But now we can. More interestingly, many of the newly identified Ganymede features aren't thought to be impact craters at all. Unlike Callisto, which is covered with impact craters and has minimal or potentially even no evidence of volcanic activity, Ganymede is volcanically active. Some of the large depressions we see then are actually calderas caused by volcanic eruptions. These weren't the first calderas found on Ganymede, and it's also not completely conclusive that that's what's in these latest images. But scientists are generally confident that these depressions were caused by cryovolcanoes. Yes, on Earth, the word volcano is synonymous with fire and lava. But on other planets, there are volcanoes that blast out massive amounts of ice or vapor, like geysers. And that's what's happening here. We do have geysers in volcanically active parts of Earth too, such as in Iceland. But these are nothing like an alien cryovolcano. The off-Earth volcanoes, like those on Ganymede, are able to spew frozen material sometimes miles into the air and out of the atmosphere. And the ice isn't always made of H2O either. It's also frozen ammonia and methane. Both volcanoes and cryovolcanoes are found throughout the solar system. Traditional volcanoes, like the ones on Earth, have also been found on Mars, Venus, Mercury, and the Jovian moon Io, as well as many more. Cryovolcanoes, on the other hand, likely exist on Ganymede, Europa, Titan, and potentially on the dwarf planets of Ceres and Pluto. They also exist on Saturn's moon Enceladus and possibly a Neptunian moon, Triton, though further study is required. For cryovolcanoes to exist, there needs to be enough tectonic activity, but also a cold enough atmosphere or surface temperature to solidify the materials the volcano ejects, called cryolava. We're also not exactly sure of the mechanism at work in the outer solar system that keep these moons and dwarf planets warm enough to support volcanic activity. A large part of it is certainly to do with tidal heating, where heat is generated from the push and pull motion between a planet and its satellite, explaining the existence of subsurface oceans within some moons. But it also may be aided by the atmosphere, if it's particularly dense and has enough gases to trap heat. Away from volcanoes, we know that Ganymede has subsurface oceans thanks to its magnetic field. Based on models of the moon, scientists have suspected the existence of such bodies of water since the 1970s. New evidence came from analysis of Ganymede's magnetic field, discovered by the space probe Galileo in 1996. Ganymede is the only moon in the solar system known to have a magnetic field, and its behavior indicates the presence of salty seas within. Researchers further confirmed this idea in the late 2010s, using images of Ganymede's auroras produced by the Hubble telescope. Ganymede's magnetic field generates the auroras, a feature also seen on Earth and the other planets in the solar system, save for Mercury. Scientists believe that the behavior of the auroras on Ganymede, which should rock back and forth more in response to changes in Jupiter's magnetic field, confirms the presence of liquid water below the surface. Juno has also been able to image these auroras in unprecedented detail, offering more insights on top of those linked to the craters. But soon we won't just have Juno to rely on for data on these moons. In April 2023, the European Space Agency is scheduled to launch the Jupiter Icy Moons Explorer, better known as JUICE. JUICE is a large spacecraft that is specifically designed to gather information on 3 of the 4 Galilean moons, rather than Jupiter itself. These moons are Callisto, Europa, and Ganymede, the ones we believe to have subsurface oceans. The cutting-edge probe is going to be equipped with all kinds of instruments to study the chemical makeup of these bodies, their atmospheres, how they're affected by Jupiter's gravity, and much more beyond. Unfortunately, even if JUICE launches on time, it's still not going to make it to Jupiter until 2031, and won't enter orbit around Ganymede itself until 2034. But we may have learned much more from Juno in that time, and it's at least inspiring to know that we'll get the data we want on the Galilean moons eventually. The 2030s are set to be a great decade for studying alien moons in general, but particularly in the Jovian system. This once mysterious part of the solar system is set to reveal many of its secrets, and these images just might be the start of that. And that's how scientists have just discovered massive, previously unknown craters on Ganymede, and why it's a big deal in the science of space. What do you think? Is there anything we missed? Let us know in the comments. Check out these other clips from Unveiled, and make sure you subscribe and ring the bell for our latest content.